this concept of staying to the left of the boom, it really is this concept of trying to have a proactive defense so that you aren't just trying to collect IOCs, known hosts, domains, and IPs that were used in attacks. And while that's definitely a part of our work, what we're trying to do is look at those. Here's one specific threat actor. Here's the groupings of domains that they've used. And then looking for patterns in that so we can detect their new infrastructure before it's even been used in an attack. And so this concept is really just identifying pre-weaponized infrastructure. And that's the simplest way to think about it. We want to know when something matches a very hyper specific fingerprint, we want to know as soon as that thing's coming online, as soon as those DNS changes are occurring, or whatever that change configuration may be. And having the tools to create those fingerprints and have them running in real time always is really the basis of our work, where we are trying to create a system, a platform, a process for proactive threat hunting. So when you think about static data, as I said, this really is the classic data that you can search in many different tools and platforms. And this is basically a host had these specific characteristics at this specific time, and it may give you a fingerprint. Maybe those threat actors have a consistent HTML title, or they're reusing a dedicated IP address, something that just it provides a fingerprint, it provides you a way to track it, but it's not that sophisticated where if they were to make minor changes, you would suddenly break that detection. And a lot of these, like what favicon is used on a website, the threat actor knows that they're creating a consistent pattern. And so what we'll see with some threat actors is they may launch with one favicon and have dozens of their phishing kits up with that. And then as soon as they realize they're being detected, defense companies are finding their stuff, they start trying to switch up stuff like favicons. And so we like to think about static data as a lot of the just simplest changes or the simplest fingerprints that are being generated by some technical architecture. And many of these threat actors know about, and they know how to change minor things in order to hide what they're doing. That's the same with APT groups, financially motivated threat actors, and everyone in between. And so these are crucial fingerprints. Absolutely everyone should be doing sort of base level fingerprinting, but change data, that is where threat actors are not prepared for this. And that's why we built our entire company around this concept of static data has to be there, but change data is the ball game. And so as you start to get into these examples that I'll be sharing, you'll better understand how we like to think about a threat actor as making decisions, basically deployment decisions, those static, and then also these change decisions in that deployment process where maybe they register their domains on a specific registrar and they age them with the name servers from that registrar. And then when they're ready to deploy it, they switch to the Cloudflare name servers or some other provider that they may be using. And that change pattern between the name servers they were using, the name servers they switched to, that creates a fingerprint. And so we've created tools to basically track changes, to track deployment decisions. So if we know that a specific threat actor is using a fast flux network, for instance, and every domain that they have rotates through 6 ASNs in a constantly rotating process where they're trying to hide their domains through this obfuscation. Well, you can easily load up the 6 ASNs within our platform, and I'll show an example about that, and look for domains that have rotated through those 6 ASNs. And we basically built these tools so that you can monitor changes, monitor new hits from changes, and you'll see a lot of tooling that we've built that no one else in the industry has really thought of. And this is the basis with which we track some of the most serious APT groups and complicated financial threat actors, this combination of static data versus change data. And so again, just the static data, it does underpin your traditional threat hunting. It's the bread and butter of when you read most threat reports these days, the threat actor is doing X, Y, or Z. This is a consistent pattern. This is the domain regex that they're using, something that gives you kind of an idea for what they're doing, but it is inherently reactive. And so when they make changes, you have to wait for it to attack, analyze that attack, and you're always a little bit behind the eight ball. Whereas if you holistically are trying to say, here's the pattern that we're looking for, and we just saw this pattern stop deploying domains, or we saw changes here, and then we immediately start looking, what did this potentially change from, and is there a new fingerprint? And so we like to think about static data as maybe the current fingerprint, and the change data helps you find those new fingerprints. So blending in strategies, query tools, basically our fingerprinting methods that can use both of these, that's where the magic really starts to happen. And so we're going to be talking more a little bit about, instead of known artifacts, attacker behaviors, those consistent fingerprints that allow us to predict the campaigns that haven't even launched yet. When those domains are aging, when those domains, the day that they switch those name server record, hours before those attacks, we want to be identifying that, have those domains or IPs automatically go into feeds for our clients to block. And that's sort of the foundation for how our threat detection in our company works.